A very good afternoon to all. In this video, we are going to solve the traveling salesman problem, which is the application-oriented case studies in the graph. Where the traveling salesman problem is the person which is assigned the task. They have to start from one position, one location, and they have to reach the end. Okay. And for that, they have to find the best route with the minimum distance. Okay. How they are choosing? What is the best route to take to visit the all the cities while they are traveling? Okay, when they are going to deliver a food. Okay. When for that, how this traveling salesman problem will help them. So these are all the some of the locations they have to visit, and they have to start from this Olympia. From that they have to reach. Okay. For reaching all the cities, they have to find the best route with the specific destinations. For finding the best route, we can use the graph concept. While we are using the graph concept, already you know that the vertices A, B, C, D are the vertices. Okay, they can call it as a vertex or the places which the traveling salesman going to visit. Then the blue color dark line which shows the edges. The edges are used to connect the two vertex. That is two places. Two cities are connected through the roads. Okay. That thing it is given as an edge. Basically, graph it will have a directed graph or undirected graph. Okay. And also we can use the weighted graph and unweighted graph. While we are going with the graph concept, there are variety of graphs out there. From that, in this traveling salesman problem, we are going to use the Hamilton circuit. It means that the routes that visits each vertex just only once, and it will take back to the position. You can consider the vertex A. If you want to cover all the vertexes, and you have to come back to A. Then also it is an unweighted, undirected graph, and this could be applied for the weighted graph also. While we are going to the weighted graph, edges are listed with the cost. The cost are it will be mentioned in the graph. It will give the least total cost to cover all the edges, all the vertex in the graph. The best Hamiltonian circuit in the weighted graph, same as our the traveling salesman problem. You can consider this graph, and these are the yellow circled values or the weights to connect the two vertexes. From this weight, we have to calculate and we have to choose the minimum cost to reach all the bets, but you have to visit each node only once. Okay. For that, you can consider D as a starting vertex. And if you compare this to 12 and 14, which one is having a minimum cost? 12. So we can travel to C. After reaching here, we have to check. Okay, 42 and 30. Which one is having a minimum value? 30. So from C we can visit to B. Okay, this one how we could judge, and we could travel to another vertex that traveling salesman has to decide. Okay. For that we have to give the solution for them. Okay. From that the solution like a shortest over all. Then, to find all possible Hamiltonian circuits, then add up the total cost of each circuit. The circuit is nothing but the vertexes which are used in the graph formation. Okay. Then consider the same example with an weight. Okay. Now we are going to calculate the cost of the nodes. Okay. You can consider the D node as a starting vertex as we discussed earlier. Then from D, we can choose to travel a C. Okay. Then from C, we have to take a decision. If you go with this route, 12 plus 30 is 42, then plus 20 is 62. This will be the total cost to cover this possibilities. C2, D to C, C to B, D to A. All the nodes will be connected with the amount of 62. Next, you can consider from D, I am going to C, so 12 plus then 42. 12 plus 42 is 54. Then from A to B, the cost will be 74. Okay, but the previous one is 62. This one is 74. And next you can consider this B to B. B to B is 44. Then B to A is 20. So from this itself we are getting a 64. Okay. Then from A, if we are reaching to C, okay, 42. So the cost will be 106. Okay. Like this, we have to calculate. If you calculate, then we will get a minimum cost as the path from B to C, then C to B, B to A. The minimum cost is 62. So after calculating this solution, it could be displayed to the traveling salesman. From this solutions, from 62, 74 and 106. From this, that particular person, they can choose any one path which is having a minimum distance, and they can travel and connect all the vertex, all the cities in that nearby places to deliver a food. Okay. Thank you. Thank you for watching.